hand this over to Arun today. Arun will be anchoring this. So, Arun, would you be okay to take it over, please? Thank you.
I'll be too happy to do that. Thank you so much. Thank you, Somnath. Thank you. You can tell me when to start. Okay.
Yeah, yes, please. Arun, we are now starting the presentation today, and yes, you can start the
Yes, start.
anchoring. Thank you.
Can we wait for some time because there are hardly 11 participants?
Yeah, we can. We can. Sure, we can. We see a
But
lot
Arun,
more
Arun is not
faces.
fair. It's not fair. जो right time आएगा वो wait करेगा, जो देर में आएगा वो join करेगा. I think not fair it is. Let us start.
Okay.
We cannot bonus to the people who are joining late.
Recording will be made available, so many people may.
Yes, that will be very fine, Somnath. Must do that.
Yes.
So,
those not speaking their mic, otherwise,
I would request all the participants to switch off the mics.
Okay, I am muting all. I'll just just to start off, and then we will get as they want to speak. You please unmute and then speak.
Can you not mute everyone else?
Yeah, I can mute everybody, which I did. And then they can individually, so that yeah, now we have got almost everybody muted. Arun, I hope you can unmute yourself and go ahead.
Sure, I'll do that.
Thank you.
So I would like to start now right on the dot. Welcome all to this very, very innovative way of exchanging ideas and also disseminating information, finding solutions, raising issues, and looking at solutions which have evolved all over the world. Good afternoon to everybody in India and nearby. Good evening to Mr. Somnath Banerjee and his team there. And good morning to people in US, maybe good evening to people in Southeast Asia. Welcome to this session. This is the second session in the series, and our intention is to continue this session every month, so that we are able to control, or we are not able really control. We are able to disseminate information to the people who are experts in this area, to the people who are practicing engineers, professionals in the field who are handling such similar projects. As you have seen that the forum name is a forum for advanced signaling, basically are largely radio based. So that precisely is the area of focus. And in the first session, we had four participants, four speakers, in fact, and we were able to, I think, talk about how to really standardize the systems, how to specify the process of approval, and then certain issues in the metro systems in Australia, certain issues about the metros in UK, and Mr. Somnath Banerjee covered it up very well. In fact, I would say that Mr. Somnath Banerjee is the architect of the radio-based systems in India, with the launching of the 18 gigahertz radio-based signaling and train control. Okay, and I would like to compliment him for initiating that system of block working on radio way back in the 1980s, and that credit goes to him. Thereafter, in fact, the first I will focus on the metro systems. I would like to highlight the achievements of the Kolkata Metro, which happens. And Mr. Basu has just entered. Mr. Basu has just joined. I would like to welcome Mr. Basu. Thank you so much for joining, sir. So I was just mentioning, sir, that the Kolkata Metro was the first metro in this country in 1984. And I think most of the participants may not be aware that Mr. Basu was the architect and the designer of the system, especially the braking system and the braking control systems. And under the leadership of, I think, the stalwarts like Mr. P.N. Gupta and Mr. S.M. Ganguly, they were able to establish the first metro in India. With this brief overview, I will go to the today's subject. And today's subject is basically on CBTC, how communication-based train control systems have evolved, and what are the issues with the interfaces, and how it can be handled. And therefore, I think we have got two eminent speakers today, and one of them, the speaker is Mr. Navneet Kaushik, who I think I can very, very strongly say that he has been very, I think, focused partner of this TMRC right from its inception. And he was able to initiate the earlier systems of distance to go systems. And Mr. Navneet Kaushik currently is the director of the RRTS, which is between Meerut and New Delhi. And also the other similar networks are coming up near Delhi. So he has conceived certain concepts which he believes, and we all also believe, that could change the way the systems have to work in the country. I would request Mr. Somnath Banerjee, if you can have got a few slides, you can share them.
Just a minute. Can you see the slides or no? Not yet. I've actually shared the slides. Sorry, I'm just trying to. I'm struggling a bit with this slide. Can you see them? Actually, I had put it on. Do you see? Hello. I think.
Yeah, actually,
can you hear me?
Your desktop is visible, but not the slides.
All right. Okay. Let me have a. What happened was. Give me a slightly different. I don't know why it is. It is trying to let me. Ah, what is this tray gone? Just a minute. Sorry. Just a minute. Why am I not getting the tray? Arun, can you do you have access to the slides? Hello. Arun, can you hear me? I don't think
he got disconnected.
Okay. No, I am.
He has come back. He has come back.
Yeah. No, I'm just trying to. I'm struggling to get the. There's a shared tray which I'm missing on my screen.
Again, we started with signal failure.
Yeah, Ajay. By the way, I think. Yeah. Just give me one more second. If I can find that, why it's just on the. It is supposed to be on the top. And you can see my calendar. Or you are able to see my calendar, right?
The calendar is visible.
Okay. Now you are actually. I'm presenting it.
Close all of those and only leave the partition open.
Sorry.
Leave all the other. Close all the other open windows.
Yeah, it's visible now.
Correct.
Yeah. Sorry. Yes. Now. Yes. So sorry for the bit of struggle at my end. Yes. So. Arun, if you can go take over, and I'll move the slides as you move. in the presentation? Can you hear me, Arun, or is it still not there? All right, I will. I'll make a quick introduction to Mr. Navneet Kaushik,
Hello.
who is presently.
I'm available now.
Yeah. Can you see it?
Am I? Hello.
Yeah, you are able to see
Am I audible?
Yes.
Look, your screen has again disappeared.
Right. Yeah. No. That's because I. Yeah. Now. Yeah.
Yes.
Okay. So I think thank you, Somnath. I think you can go to the first slide. I think some more people have joined, so we can start maybe in another 2 minutes. So the today's session basically is on delivery and interface of CBT systems and how the management handles it effectively. And there are so many metros which are mushrooming all over the country in India and also happening all over the world. And therefore, I think we have got two eminent speakers today. I briefly talked about what the focus of, next slide please. What is the focus of this particular group, Advanced Signaling Forum, which is largely focusing on initiatives in the area of ETCS, CBTC, and other signaling systems which are being deployed all over the world, which are largely radio based, including the ITCS, the TCAS, the ETCS level 2, the concept of hybrid level 3, which I think Navneet will talk today. And next slide, please. So this I have talked about. I think which the primary focus is basically to share information, share whatever practices we have been following in the past, and what can be done, what are the issues in the field, what are the problems faced, and how we are going to improve on them. And it is basically for people who are working in the field of radio-based signaling who can take advantage of this particular forum. Next slide, please. So I will now come to today's subject, that is the CBTC delivery interface and management. This is basically a very important subject, and without this, I think most of the CBTC projects have failed. And we have got two eminent speakers, Mr. Navneet Kaushik from the NCRTC, and then Mr. V.K. Agarwal he is the Director of Systems at the Pune Metro. I'll just talk briefly about Mr. Navneet Kaushik. Mr. Navneet Kaushik is basically an S&T engineer of Indian Railways, but he moved into the more innovative and exciting area of metro systems way back about almost 20 years back. And Mr. Navneet Kaushik now has almost 33 years of service experience in the field of railway signaling, and currently he is the director of the RRTS, that is Rapid Rail Transport System between Delhi and Meerut. And there are similar networks coming around Delhi. I think so he is the key person from that angle, because the intention is to have a uniform signaling system which can handle the entire periphery of Delhi area. And therefore, he has taken a very, very innovative step of going into a concept wherein he has full control over the headway, and therefore taking advantage of the current technology, especially the LTE, which I think they will later migrate to FRMCS, and the second one is about the ETCS level 3 hybrid. This concept I think he will very well be able to explain, where he is talking about, apart from the train detection devices available, there's a concept of controlling an optimized virtual block, and that is the way it is. You are able to get a good headway, or the required headway, and that is what is feasible. Mr. V.K. Agarwal is also an S&T engineer, and I have had the experience of sharing some time with him in Austria, and he is such a dynamic person that he's out to deliver anything and everything. And he will be just talking about what were the initiatives taken by him in Nagpur Metro and the Maharashtra Metro and now in the Pune Metro. With these few words, I will now invite Mr. Navneet Kaushik. Mr. Navneet Kaushik will be delivering the first talk, and after that we will have maybe I think the questions can be taken at the last in the end. We can start with Mr. Navneet Kaushik first. Mr. Navneet Kaushik, please.
Thank you, sir. Good afternoon and good evening, everyone. In fact, sir, I didn't plan for ETCS hybrid level 3 because the topic was challenges or the interface management in CBTC. And as the first slide has already been shown, wherein it shows that I have already been involved in a couple of CBTC projects, right from the first CBTC implementation in India, that was in Kochi, and then later on Delhi, and of course I was involved in Hyderabad Metro, as well as initial phase of Mumbai line to line 7. So I thought of sharing few of the challenges or few of the important issues which I had faced, and probably anybody who is going for CBTC project now can definitely consider those. I have picked up only very few cases because I can understand that the way, and I can see the names who are available here. So most of them probably know what CBTC is. So I'm not going into the technical part of it because that will be like something which probably might have already been covered. And then as far as ETCS is concerned, yes, we in NCRTC are implementing first ETCS level 2 in the country. And not only ETCS level 2, we are also implementing ETCS hybrid level 3, which will be probably the first in the world. Along with that, NCRTC has also decided that they will have LTE as a communication backbone instead of GSMR. That's another challenge for us. And over and above that, there is one more important thing which we have added to it, and that is implementation of platform screen door on the RRTS corridor. That's another big challenge because till now, no one in the world has implemented platform screen door with ETCS level 2. Further, we have decided to add ATO over ETCS level 2 or hybrid level 3. So that way, this project NCRTC first corridor, Delhi Meerut corridor, will be a showcase of all the latest technologies in the world. And we are working towards that so that it is successful. Further to that, if I can say that once it is implemented, I'm quite confident that probably people can go for ETCS level 3 or hybrid level 3 for even metro projects, and we could perhaps see the end of CBTC. We could, because all the advantages those were available with CBTC will be available in hybrid level 3 and finally level 3. And in Meerut corridor, Delhi Meerut corridor, the last 10 stations out of the total 25 stations, last 10 stations have a mix of MRTS and RRTS. So virtually we can say that the last 10 stations, which are 1 kilometer apart, is actually a MRTS implementation. So once that is done, then one can imagine that if that is successful, then probably CBTC will not be needed in future. And one of the important reasons for that is that CBTC is still proprietary in nature. So whenever you have you have to go for extension or addition of new lines or addition of new stations, you do anything, you have to go to the same vendor. So with this background, I will start my presentation, and I have not covered either CBTC technical aspects or ETCS level 3 aspects. And as Saxena sir has told, I was not aware of it that I have to share level 3 also. Otherwise, I could have done that because that's the area in which we are working. Right. So I have picked up only few challenges which we have faced with regard to CBTC implementation, and that is what I will present. So I hope my screen is visible.
Yeah. Go
Okay.
ahead. Go ahead.
Thank you, sir. Go ahead.
So one of the major change that has happened in last few years, especially in Indian context, if you see, we were working with distance to go signaling, which was track circuit based. And track circuit based means one-way communication with the onboard and track side. So track side could speak to the onboard through the track circuits. And that was one-way communication. But once CBTC was introduced, it became two-way. And the major difference that took place was that the location determination was through radio. So, and since the granularity of location determination became very sharp and very precise, so it was possible to go for moving block. So with CBTC entering into the arena, we shifted to moving block from distance to go, which was earlier track circuit based, and the reason was this. And once moving block was introduced, the demand for shorter headways came, and that was easily possible. The next item, which is very important, especially in the Indian scenario, is whether we can reduce the capex. And the basic issue that comes up is that do you require backup signaling or not? Because the moment you decide that backup signaling is not needed, then there is a huge saving in capex. However, in the orthodox scenario in which we live in, particularly in India, it's very difficult to remove backup signaling. So in India, we never thought of removing the signals, removing the backup train detection, and thereby we increase the maintenance cost, capex, opex, everything. And I will take a few issues here, which in fact crop up the moment we introduce backup signaling. And the last point, of course, which I have already said, that CBTC still remains vendor specific, which is not the case with ETCS. So the moment the choice for CBTC came, the questions which were raised and which were easily handled were the choice of frequency in ISM band. So that in any case, all of us know that two ISM bands were available, 2.4 gigahertz and 5.8 gigahertz, and there was a limited choice. Of course, in other countries like in Bangladesh, they have already started implementation of CBTC over LTE. So all those options are available, but in India, there's not much choice available. It's only 2.4 gigahertz and 5.8 gigahertz ISM bands available for radio backbone. Next question, the moment we talk about this Wi-Fi, is the choice to be made between spread spectrum technique to handle missing packets and handling the noise. So choices available are FHSS, DSSS, or OFDM. And of course, what I've written is that no choice available because it is vendor specific. Each vendor has its own technique of implementation. So like if I am allowed to name the vendors like FHSS, Thales uses FHSS or DSSS is used by Bombardier or OFDM used by Alstom. So everybody has its own method of implementation. And I've been lucky having worked with all the three. And each has its own advantages, disadvantages. So that is about the modulation techniques available. And of course, most of us know that FHSS, that is frequency hopping spectrum, is the best choice available for interference. However, the other techniques are also equally good because they have, in fact, I know about DSSS because it was made proprietary and the spectral density was handled in such a way that the signal strength, actual signal strength was much more than the noise. So all these choices are available, but this choice is available with the vendors, not with us. And then in India, as I already said, that we don't have courage to go without backup signaling. In fact, right from day one, we were not interested, but seeing the scenario here in our country, we had to go for backup signaling in all the CBTC projects. And I'll take up some issues which, in fact, creates further problem the moment we decide about backup signaling and we introduce extra failure cases, but we feel comfortable with that. So we'll talk about it. Now, the decision of backup signaling can be seen in context of these things. Trackside ATP redundancy is available, full redundancy is available. Onboard ATP, full redundancy is available. Interlocking redundancy is available. Fiber connectivity on the trackside between, say, interlocking ATP or any other thing, full redundancy is available. Radio, enough diversity, enough redundancy is there, so there's no question of failure at the radio end. Therefore, one can say that this is enough. However, we decided that we'll go for backup signaling, and therefore we had to introduce Excel counter and signals. And the moment you do it, we create more problems. And the only reason why we stick to this particular decision of backup signaling is that we feel comfortable in handling the operation in a degraded scenario. But the first question which we are not able to handle is that why at all this failure should come and why at all this situation should come that we have to go for degraded condition. But then what I've seen is in my last 16 or 17 years of experience with metros and rather metros, the equipments, those work very well in other countries when those are implemented. Here in India, the kind of harsh environment scenario which we have, we find we have seen a lot of problem with those things. So we feel more comfortable with providing backup signaling so that we are more comfortable in handling degraded scenario because we feel that this particular condition will come more often. So the basic decision on which backup signaling rests is ease in handling degraded operation. But if you don't have backup signaling, there is a major saving in capex and opex. However, the degraded operation becomes very cautious or difficult. And as part of backup signaling, you add signals, you add Excel counters or track circuits, and in terms these items we have already talked about. So the moment we add these gadgets of backup signaling, the other problem starts. And I have specifically picked up only these 5 cases for consideration. And the first one is the moment I put up signal and its overlap, it starts impacting the headway. And not only headway, it starts impacting the recovery scenarios of failures. Whereas if there are no signals, no track circuits, no Excel counters, and you are working in moving block, the operation is quite smooth. So I'll take up a few cases and we can see each one by one that what happens when we provide signals, what happens in case of tunnel areas, what happens if we provide PSD along with CBTC, and what is the consideration for train relocalization? I missed the word relocalization. It is localization, so it is relocalization after it degrades into non-ATP mode, and the impact of track layout. So the moment we talk about placement of signal to handle the degraded scenario, then a lot of questions that come up are, I have just drawn a picture just to explain that. The signals, I'll just show you, this is the platform and this is the station stopping point. Yellow one is the emergency braking curve and the dotted line is the advisory curve, which is used for stopping the train at the station. So the moment we say that we want signal, the question comes is where to keep the signal. And if signal is provided, how to handle the emergency braking curve. So in the first scenario, when if you put the signal exactly at the end of the platform where your station stopping point is, so virtually what happens is your EB curve and the advisory curve almost matches, coincides. And when it coincides, it's very difficult for a driver to handle this because there is always a possibility of encroaching into the EB curve and EB may be applied. So this is one can say that, okay, this is not a good location to put a signal. The second thing can be you can provide signal at some distance from station stopping point, which depends on, of course, the ATP overlap or because you see, if more this distance, one train can enter at very high speed and stop at station stopping point. Virtually, you save on the time, and so actually the headway or the overall run time reduces the moment you allow this, because now the EB curve is at the foot of the signal. And the third scenario can be, which is also there and which is also implemented by many vendors, is that the signal, the EB curve goes beyond the signal. Now, this particular scenario doesn't match with the mindset of our country, because we feel that train should never cross a red signal. Actually, this is something we people have to understand, that as long as ATP is there, signal is no more needed. But our mindset is such that we feel that signal is something which can never be, a red signal can never be crossed. So this is one aspect which is to be considered when we talk of backup signaling, and one has to take a judicious decision, judicious call based on different scenarios, because you see, this crossover which is in front of the station could be very close, could be little far, and that will decide the flexibility available to you for this. But I would like to draw your attention to the third option, which is which shows that the EB curve protects the point or the crossover and not the signal, and this is acceptable in the industry, which is required to be accepted by us too. That was one aspect of providing backup signaling. The second one is, the moment we provide signal, again, our traditional mindset, we have to have a signal overlap. But why signal overlap is required? Because in my opinion, that is not required. And let me explain you the scenario and the problems that it creates. The moment you provide a signal overlap, that means you are providing extra set of already you had decided about, we had decided about backup signaling. So we provided a signal, we provided Excel counter. And since we are now providing signal overlap, we provide another Excel counter here. So what happens is that the moment, and the those who are working in metro signaling environment, they know that the moment overlap is cleared by the train, the signal turns to violet and another train can be given authority to proceed beyond this signal. But in turn, what happens is that if an Excel counter fails, so virtually the entire section becomes unavailable to the train to run in ATP mode. So virtually the train will go in degraded mode in the entire section. So what has happened is that in the process of providing this degraded operational efficiency or operational confidence, we have introduced one failure in the form of signal and another failure in the form of failure of Excel counter. So so one has to take a call whether we really need backup signaling, and if at all backup signaling, whether you need overlap. So then one more case I have picked up, and that is about restriction due to tunnel ventilation. You see, this is, on one hand, we are providing moving block. We talk of headways less than 2 minutes. And on the other hand, you can see that whenever there is a tunnel section and these are two ventilation shafts, so automatically a restriction is imposed by these people that a train in one tunnel ventilation zone, there can be only one train. So this is one aspect which.
Kaushik, I think now it has become 2 trains. I think NFB has given allowed 2 trains now.
No, okay. I'll explain to you that also. In fact, if you read the NFPA document, it says that you can take second train with procedures, right? So that means procedure means what? Procedure means that you have to have some written instructions that in case if fire takes place, there are 2 trains in the ventilation shaft in a ventilation zone, and there are 2 trains, and if fire takes place, then those procedure orders have to be in place, in which the driver of the unaffected train knows that he has to turn back and take back to the previous station or go to the station ahead. So NFPA only allows that, but it doesn't allow 2 trains. 2 trains, because the moment one train is on fire, and when it comes to the passenger safety, you can't allow more than 1 train in one ventilation zone. Of course, this is one area which people usually ignore because they feel that fire is is an instance or is a condition or is an occurrence which will occur rarely. So they ignore it, but the fact remains that system as per NFPA wants that there should be 1 train in the one tunnel ventilation section. And if you allow the second train, then you must have procedures in place so that you can handle the accident or fire scenario. So this is one item which I picked up because on one hand we talk of shorter headways and on other hand we are putting up these restrictions. I had drawn these when
generally the metro scenario is such that the interstation distances are generally about a kilometer average. So about a kilometer average is you are able to afford easily 120 seconds operational.
So that's what I said, that you can easily achieve 120-second headway, but what about getting achieving headways less than 120 seconds? That is one item. The second thing is that if there is a failure and if there is a bunching of trains, then how to handle that scenario? So once the bunching takes place and then you have to normalize the system, it takes a lot of time because there is a restriction already that there can be only 1 train in a ventilation zone. Of course, as somebody said that 2 trains are allowed. Yes, procedurally it is allowed and it can be handled. But this is one item which I
2 trains if required.
That's right. So this is one item which I read just for attention of everyone that how, and this item has to be considered. Okay, this is another important aspect, which is the moment we have platform screen doors along with any radio-based system, then there is automatically introduction of extra time delay. Why? Because the train, the door opening and door closing command from the train has to go via radio to the trackside ATP, then to the interlocking, then to the station object controller, and then to the PSD controller. So virtually it takes around 4 seconds. So 4 seconds for opening and 4 seconds for closing, that is introduced automatically if you have platform screen doors. So platform screen doors, we already know that if you have to, if the doors have to open, it takes around 2.5 seconds and close 3.5 seconds. So around 6 seconds are there for door opening and closing, plus 8 seconds for this control command to travel. So what happens is that this 8 seconds, which was otherwise available for the dwell time, is not there. So if in a normal case, if the dwell time is around 30 seconds, 6 seconds for door opening and closing, which is 24 seconds, and then another 8 seconds for command travel. So that is the time now left for dwell. So one has to take a call how to handle these things because the only option that is available is that one can have another set of Wi-Fi system from onboard to the station directly this is what we had. In fact, I was again lucky to have commissioned such a system on line to 6 stations. That was a retrofit PSD work, and we provided VHF system on board and on the station, and the command time we were able to reduce to almost 1 second instead of 4 seconds, and that was huge reduction as far as the command travel time is concerned from the onboard to the station. So this is one area which, of course, everybody has to really take care of. If
small interruption here, I think distance to go, we have 300 milliseconds for these communications. Here in CBT also we wanted a 300 milliseconds between signaling and PSD communication.
So in fact, no, I will. In fact, if
excuse me, what I would suggest is let the presentation be completed and then we can go to the specific questions.
Right, sir. But still, I would like to clarify this particular question since it has been raised.
Yeah.
First of all, if any vendor is saying that the command time is 300 milliseconds, then I would say that it is absolutely wrong. The reason is very simple. You see, the command has to first go to the onboard ATP, which itself has a cycle time of 500 milliseconds. Then it has go to trackside ATP, which has a cycle time of 500 milliseconds. Then the very small time, of course, this time is very small, which is used by Wi-Fi, the latency from onboard to trackside. Then it goes to the interlocking, another 500 milliseconds, and then it goes to the object controller, another 5 million. So automatically, at least 2 to 2.5 seconds is reduced. And there are then further delays. Suppose if the packet or the message is lost in the first cycle, then you have to, this 500 millisecond automatically becomes almost a second. So on an average, if you will see this time, if it is not directly from the VHF, but via the CBTC route, then the time will be of the order of 3 to 4 seconds, and this can be verified. So this has to be taken care of. So this is what I wanted to highlight. And
this very second, but we have also provided similar system, but there's a direct communication established between the onboard equipment and the station object controller. We have established a communication. So we are able to mitigate this, and we are able to achieve a total dwell time of 30 seconds. Within that 8 seconds, we are able to opening and transmission of signals. So signal through the interlocking directly communicates to the station object controller.
That's what I said. If the metros have arranged direct communication from train to station, it is the best.
Independent system. It's the same CBTC system only, same radio.
Anyway, so I can discuss it further once the presentation is over. Right. Now, the next item is train localization, or I said relocalization once it degrades. Now, this is another important thing which all metro engineers must understand and should handle. And what is that? A general perception is that if the train degrades and it has to relocalize it has to pass over 2 beacons. This is a normal understanding. Now, this particular item or this particular issue has 2 basic conceptual requirements which need to be understood. One is that the odometer itself is able to determine the direction of the train movement. And the second thing is that if the metro system which is there any possibility of change of train orientation? Is there any possibility that the front head can become rear head? So this is generally, it takes place only if there are 2 entries in the depot. There is a Y, and then there is a possibility that train orientation can change. But if it is not there, there is no possibility of changing the orientation of train. So the moment we know that in our system, orientation cannot change, and odometer is in a position to give direction also, then just by crossing the first beacon, train can relocalize and go to ATP mode. So this was the purpose of taking up this point. The purpose of taking up this point was to tell you that instead of running for two beacons, which could be at a distance of 300, 400 meter, whatever as per design it has been decided. So the relocalization can take place at half the distance, and which can save a lot of time if there is any degradation, or if there is for some reason we have started the ATP and then it has to relocalize. So this is one aspect, because generally what I have seen is that engineers ignore this particular fact that in my system, I will never have a Y for depot entry. And if it is not there, why should I even consider this particular aspect that we will require two beacons for localization? So this was one item. And of course, the last item is track layout. Track layout, I initially wanted to draw few layouts, but I left it. It is just to tell you that track layout has major impact on headway. So on one hand, we talk of CBTC, moving block, but the track layout is such that it doesn't allow good headway, good turn back time at the terminal stations. So it causes a lot of problem. So some of the items which I have listed here are simultaneous reception and dispatch should be possible. The overlap has to be decided accordingly. Fast, it allows fast entry at the platform, thereby reduces travel time. One has to decide whether two single crossovers are good enough or we should have scissor. Crossover speed is another important issue, because generally we have taken it for granted that in metros 35 or 40 kmph at crossover is sufficient enough. But if we have to talk of better headways, then probably we can think, one has to think for something more. And crossover distance from platform edge, of course, this permits faster entry of the train onto the platform, and then provision of ATP overlap is taken care of, and then handling missed section reversal. This is also an important aspect when track layouts are considered. So that was about track layout, and since the time was limited and I was asked to speak only on few things, so this is all from my side. Thank you, sir.
Thank you, Navneet, for a very, I think, in-depth and maybe enlightening talk about various issues which you have referred to. We will have some short discussion after we have the next presentation, and the next presenter is Mr. V.K. Agarwal, who is the current Director Systems in Pune Metro, and I would request Mr. V.K. Agarwal to kindly take over. Mr. Vinod Kumar Agarwal. He is also an SNT engineer of Indian Railways, currently as Director Systems, Pune Metro. Vinod, please.
Thank you, sir. Although I'm a SNT engineer, but I joined Pune Metro as a Director of Operation. Later on, I have been given responsibility of system also, including electrical. So most of my time in proving to management that SNT engineer can also manage electrical and other systems. So my exposure to CBTC is very limited, but I will just present few of the management difficulty handling with the signaling system and introduction of CBTC. Pune Metro, we have two corridors of north, south and east, west. Nagpur, we started the tradition of a priority section, wherein we commission 4-5 kilometers with basic signaling without CBTC. And this was appreciated a lot by city because they face lot of difficulty metro construction. Similarly, in Pune, we have been mandated to provide priority section. Now, Pune comprises of two cities basically, PMC and PCMC, and both are competitors. So we have two priority sections. So initially we didn't have our rolling stock contract got delayed. So we got 4 train set from Nagpur. So we thought of commissioning this priority section with CBTC. There our struggle started. Now we have a storm signaling system and CRRC rolling stock. Both have never there were no interface history between these two systems. So we struggled for 6 months to provide an interface between signaling and rolling stock. Afterwards, we came to conclusion that cost and time required may not be. This won't be a wise decision to go for CBTC in initial section. So we decided to go for basic signaling with signals and Excel counters. Now CBTC, we plan to introduce CBTC in different reach to in the beginning. Now I will just present what are the problems we are facing as a signal engineer in convincing the management why it is taking so much of time. Why change of certain track parameter or a track layout impact the design duration. That is my basic challenge. Really don't know. This is my first presentation on.
I think you should have a small arrow somewhere on your control screen. You have an arrow there, a arrow pointing up.
No. Yes, I'm trying that only.
Yes, you go to the window and probably the window which has your presentation can be selected.
Really don't know.
Okay, there is one way. If you can quickly transmit it, we can. I can show it. Otherwise, yeah, as you continue the discussion, you may quickly transmit it.
You can just send it.
Go
No,
ahead.
anyway, instead of showing the presentation, just I can discuss. Like for CBTC design, we need a design input as a contact specification, track layout, track GAD, rolling stock characteristic. These are the input required. Based on these input, we prepare, contractor prepares the preliminary design. It takes approximately 2 months. After approval of preliminary design, then application design is being prepared. Again, it takes 2 months. Then system database generation, again 1 month. After that, we do the subsystem database generation, ATS, CBI, ATC, MSS. Then factory integration and validation. Meanwhile, site installation is already in progress. Afterwards, we do the track survey to verify what data I have considered, whether it actually matches with the site data, because site always there are certain changes are there at site. Then testing and commissioning, and finally after safety validation, we commission the system. Now the system design cycle again, from the contractor side, they do the document planning, document is prepared, review, verification, approval. Then it comes to metro, wherein it is being reviewed by GC and Maha Metro. If it is approved, we can go ahead with the implementation. Otherwise, again, that same cycle is repeated. Now this is the process. Now what the challenges we were facing in Pune Metro, even for basic interlocking, I will tell. Earlier we decided for a priority section of consisting of 5 stations, 7 kilometers. But because of political compulsion and eagerness of management to show that we have commissioned some part of metro, because of failure of civil contractor, we make it 2 stations. Meanwhile, due to corona impact, everything got delayed. And however, we progressed on civil front. Again, we changed it to 4 stations. However, again, some problem kept in, and 2 stations which were in between, it was not possible to construct those stations. So we decided to skip those 2 stations. Afterwards, condition improved. One more station was included. So in overall, priority section 1, consisting of 5 stations, 7 kilometers, we changed our planning at least 10 times. And you can now see, most of the changes were in the every 2 or 3 months or 4 months. By the time contractor have already moved ahead with the design. Now management is expecting that whatever changes are gradual, design should not take much of time. When we speak to the contractor, he said, even if there is one parameter gets changed, complete process needs to be repeated. This was the one challenge we faced. Similarly, priority section 2, we have 5 stations, 5 kilometers. Again, because of change in priority, at least 5 to 6 changes have already happened, and we are still struggling to commission with basic signaling. Now, CBTC reached to, we have 10 stations, and viaduct, out of 10 kilometers of viaduct, only 5 kilometers is ready. And only 5 stations are nearing completion. Remaining 5 stations, work is not yet started. Now, target is to commission CBTC by April, and we have received the rolling stock in October. Now, just we are starting the static test and other tests, and all those processes will take place. Now, CBTC design, when track GAD and scheme plan were given, contractor started the CBTC design. Meanwhile, track GAD, again, there were gradual changes because of some land issues, some alignment got changed. Again, track GAD changed, and again we had to start up from fresh. Now, contractor is saying that it will take at least 6 months to prepare the basic design. And afterwards, site track survey, and like after design, this needs to be matched with the track survey and other low speed trial, high speed trial. Now we have been given time for 3 months to complete all these activities. And even now, I am not sure how many times my track GAD will change, how many stations I have to skip because access issue is there. So basically, I joined this forum to learn from you learned people how to tackle these issues from management point of view. And one more issue, when the impact of design in the cost. Like contract, we have simple cost center is like preliminary design, application design. Now these frequent changes, contractor, most of the contractor, my experience is that OEMs are quoting very low rates. They are knowing that there will be a lot of changes and they can claim very high amount of variation. Now again, I'm finding it very difficult to prove the management that cost quoted by contractor because of these changes is justified. Because there is no document as a contractor is not yet submitted the design, and we are changing the parameter like track GAD, alignment, and so many other things. So like a lot of experienced people are there who have experience of commissioning CBTC across the world. So I would really like to know from you all, what can be done to tackle such scenario? Because I'm still struggling. Thank you.
Thank you, Vinod. I think you have raised very pertinent issues which almost every signal engineer faces, not only on the metro system but also on the main line. And issues you have raised are very important and they have to be handled effectively. Thank you so much. Now I would just like to summarize what Navneet was talking about, and from there I will mention how it has to be taken forward. Uh, Mr. Navneet Kaushik, I think, has given a very clear observation on different issues and challenges which he has to face while commissioning CBTC. He mentioned about that he is not come prepared with the ETCS hybrid level 3. I fully agree there, because that precisely was not the subject. But the intention of raising the issue was so that in the next subsequent sessions, we could consider this aspect, because this is the likely future, as he himself mentioned, that ETCS hybrid level 3 could be a way of resolving the issue of proprietary systems of CBTC, which are troubling almost every metro organization. He has raised very important issues regarding the working of the system, and the main issue which he has raised is about the backup requirement, which I think in the conservative behavior which we already almost all of us have. I think that approach has been sailing through for the last almost 15-20 years. But I think that now the time has come, I think, that we need to focus on strengthening the redundancy in the system instead of going for the backup systems. And that will be giving a very big relief in the costing of the system in terms of the capex as well as the opex. Uh, and the issues which he has raised are also about, I think, what are the issues which really trouble the headway, or which I think degrade the headway or spoil the headway, also have been raised by him, which I think there were certain issues on that. We can discuss those. I would now throw the session open for the participants. If they have any questions from Mr. Navneet Kaushik, please go ahead with the questions. If you can put it in the chat box, I think that can be seen by Mr. Somnath Banerjee, and he can also raise the question. And the other speaker, Mr. V.K. Agarwal, has raised very significant issues about the challenges of the changing scenario at every stage because of whatever reasons. And for this purpose, especially for the mainline signaling, we have focused on the thing called design, automation, and simulation tools, which are computer based. And the design, automation, and simulation tools, if you got, then the design time and the simulation time substantially reduces, and you can do the design as fast as in less than a week. Thank you so much. I think now the questions can be raised. Thank you.
Could I tell it verbally, the question?
Yeah,
Yes,
please.
I've got 2 or 3 things to say. Number one is that the cost, Mr. What's his name, Navneet, has talked about the standby, and that already we are taking care of certain duplication, etc. Why don't we eliminate the backup, that is the line side signals and whatever it is. Now, he has also pointed out that restoring from a backup to the actual system when it comes into working, that has some complications. In fact, that is a subject which needs more thinking. Now, I wanted to say one thing, that when we talk about backup for fail-safe systems, it is totally different from non-fail-safe systems. On-board equipments have fail-safe systems as well as non-fail-safe systems. What are they? The fail-safe system is the CATP, which really gives you the safety, and it decides the envelope under which you can work on a speed distance graph. Now, as far as the ATO is concerned, it is a totally what you call non-fail-safe system. Now, when you talk about redundancy for ATO, duplication is the straight-off process. And there's no question of 2 out of 3 and 3 out of 5 and whatnot. But the moment you come to safety, either you have to have it in series, or you will have to have duplication of that series path by 2 out of certain systems. Now, my experience has been in the earlier days, and my experience is based on from 1975 to 1984 of various countries, lots of literature and things like that. And I had gone into quite a lot of depth. Now, the basic thing is that these metros which I've seen, for example, I can name it the Leningrad Metro line number 3. That was the first, I can tell you, in the world when BART failed in San Francisco. And I know the reasons why it failed. And I only hope that our people who are doing the TCAS doesn't make the same mistake. Anyway, it has been documented. It's available in Metro Railway Calcutta, and one can easily draw why it failed. Now, the one which succeeded was in Leningrad Metro that used a central computer. Now, any concept, I can quite say it with quite a lot of belief and proof that any system of train control other than a central computer control can never, never, never optimize headway. Even in central computer control of trains, there's a thing called a group control philosophy. We didn't know. We initiated it in the metro. It was approved. After we got it approved, in fact, there's a paper of mine in the IRS TE magazine, 79 April. And in that, the train control philosophy has been spelled out where the concept of group control came up. Without group control of trains, you just cannot optimize headway. And in other words, it means a central computer. Now, a metro situation is ideal for a central computer application only for this reason that the rolling stock characteristics, which you may have 2 or 3 different types of rolling stocks, are more or less similar, having an acceleration of the order of 1.3 meters per second squared, and retardation of 1.1 meters per second squared, that sort of a thing. So what is really going to vary is your acceleration curve and your braking curve. And of course, coasting also, the rolling distance and all that, which is developed from the train characteristics. Now, I am really surprised that these concepts which were established so many years back in the last talk, and of course, I'm giving comments of the last talk, and in this talk, nobody has touched upon this idea of the central computer system coming in. And number 2, today with the moving block concept, it is absolutely imperative to use it. And we are talking about so much about train-to-train communication. I think that goes to a decentralized system. Now, I have myself time in 1978 in the Leningrad Metro, how not at one station, a sustained headway of 75 seconds. We are talking about 120 seconds today. The Calcutta Metro was designed for 110 seconds, for 90 seconds. But what we can get is only 110 seconds. How the Russians got 75 seconds was an eye-opener for me, because I didn't believe it, and when I timed it, I found it so. So I wanted to find the reason. And the reason came out of the central control computers group control philosophy, which, as you know, they never told us. It took us about 3 months to evolve the philosophy. A paper was published, then the Japanese published a paper. The Russians knew it first. They probably never published anything.
So,
And then others also did.
Sir,
yes.
I think we will have a very, very separate session with you. I think you have got extensive experience on this. I would just now request Mr. Navneet Kaushik to kindly respond to the issue of whether the centralized computer option, which Steve Basu is suggesting, what are his views on that?
Yes.
Thank you.
Yes. Sir, as you rightly said, that we must go for centralized computer operation. But one must also accept one thing, that the kind of interference we have with the cabling system, which is of course redundant, but still, in spite of redundancy, creates problem. In fact, in Kochi Metro, we provided all the interlockings at one place, and of course only the object controllers were at stations. And we were able to handle it, but the fact remains that in case of failure, how much area is affected? That is the core question and has to be answered. If it is distributed, so only one computer has failed, but the balance area, the complete train control system is available. However, if you centralize it, and if something happens to the centralized system, then the entire line is out. So it's a conscious call which one can take.
Thank you, Navneet. Any more questions? Any more observations?
I'll just, this is to Mr. Kausal. I'd like to, he raised this question of the overlap and how it, whether it is really kind of useful or not. Now, I'm facing this issue quite here, though not on a CBTC, on a ETCS system, where the overlap is being provided, but there is no justification for that on the modeling. That is, it is not appearing to be helpful in for the headway. So I am of I came to the kind of conclusion that maybe unless it is unless you can put a train in the overlap, why, and you bring in another train behind it with obviously their braking curves of the succeeding train will be controlled. There is no gain. Is that something which is correct for me to say?
In fact, as far as the headway is concerned, I would say that it really doesn't impact much, because whatever is the headway and the distance decided about the headway, sorry, of the overlap, I'm so sorry. So the whatever we decide about the overlap length, it really has no impact whatsoever on the headway as such. But one thing is definitely there, that we are putting a restriction that if there is, suppose we provide overlap of 100 meter, then two trains can't come closer to 100 meter, but that scenario never comes. So in my opinion, overlap being there or not there doesn't matter. Only thing is that our mindset says that if there is a degraded train and if he misses the signal, then there has to be some area over which the driver can react and stop. So this is a call which is to be taken, because there are many places, those who do not even cater to overlap requirement.
Yes, I think So you kind of confirm the fact that overlap is a mindset rather than a necessity.
In fact, just to mention to the group, if you look at our own rules in India, there is no overlap in single line automatic section. As per GR, there is no overlap.
Absolutely, sir.
And it is very strange that it is there in double line section, where you are very much aware that the movement is directional, and you are very clearly aware that how the trains will move. In fact, with the multiple aspect signaling and now ATP coming in, the train is largely under control. So obviously, even if, in fact, if you look at the data on collisions in the Indian Railway, the automatic signaling section collisions have been at a very low speed. And that itself gives an indication that we have to have a rethink on the overlap. There is also a reference made to the railway board on the subject that the overlap in double line should be abolished. Welcome, Mr. Manohar. Welcome.
We should compare the cases of spots also. How many spots are still taking place? So let us not just talk of collisions. There are plenty of spots. Spots are not reducing at all in the Indian Railway.
Mona, we cannot hear you. You are muted probably. Please go ahead, Tuteja Saab.
Welcome, Mr. Manohar. If you want, I think you have to unmute yourself. Please unmute yourself. Yes. Please
Hello?
unmute yourself.
Today, you can continue while Manohar solves his unmuting. It is very nice to see him. Thank you.
It will get solved only by ADP. There is no other way. And secondly, there is another issue of centralized computer control. Actually, if you see, our metro systems are all working under a centralized control of a centralized system only, of the zone controllers and the central computer of ATC, the operations control center. So we are actually, except interlockings are just distributed, as Navneet rightly pointed out, that to sort of mitigate the disasters of a central place. So that centralized control system is already operational. And autonomous trains, I think only Australia has tried that too, only for goods trains only. So far, I don't think autonomous trains have been attempted anywhere in the passenger systems.
Today, I think there's a slight difference here. There are a number of controllers on the wayside. There are a number of controllers on the car on the onboard, and there is also a central controller. So obviously, when you've got such multiple controllers control systems there, then there obviously will be some kind of a latency emerging into the system, which I think Navneet was talking of.
Yes, you have to have an onboard system. What maximum you can do is you can centralize all the zone controllers in one place. But onboard control system has to communicate with the central system in any case. Without that, you have a train operation.
No, Mr. Saxena, this method of group control of trains takes into effect any departure at 1 point, 3 points, 5 points. If somebody goes through that philosophy, which is already put in a paper, one will understand how to bring back trains to normal by a central computer. And as the gentleman just before me has said, the central computer system obviously is not something new of today. It must have been in many of the metros, and I'm told something like that is there in the Calcutta line number 2.
Okay. Sir, Manohar, are you there?
Are you able to hear me? I am using my cell phone.
Yes, we are there.
I'm greetings to all of you. My question to Kaushik.
Yeah.
So he has been telling me, this is very basic fundamental question. He has been telling about centralized operation versus distributed operation of CBTC. Okay, but then from railway board, when I was AM, I was able to have when look into that Hyderabad metro, which was the first one to come as a CBTC signaling for metro. But then almost several years have been passed. Have we not standardized the CBTC signaling for the metro system in Indian Railways, in our metro system? Still, we are talking about the distributed versus and centralized operation. So I wanted to know from Kaushik, because he has been there with the Delhi Metro from the beginning.
Sir, let me tell you, sir, that this issue has always been left to the metros, and it is up to them to decide whether they want centralized or decentralized operation. Because what I have found is in a protected environment like what metros have, it doesn't matter whether it is centralized or decentralized. Right. But yes, of course, we have not standardized it.
Okay, thank you, Naveen. I think that
and one more second question. This is also very basic.
Yeah.
And you have been talking about the yard layout, scissors crossover. As a policy, I think in many railways, all these crossovers are not to be implemented, not to be laid. So is it still an issue in metro?
Sir, actually, I can tell you that according to me, one is maintenance aspect and the issues related to scissors. But as far as metro low headway requirement is concerned, the scissor is the best choice. A scissor in the rear at overlap distance away is the best choice.
Because scissors is not linked with the high speed, so you are probably going in for that. But in railways, as a policy, we are phasing it out.
Okay, thank you, Mr. Manohar. Thank you.
Speed, one in 9 300-meter lead radius. We are allowing 40 kmph in any case, so that is a pretty good speed. Whereas Indian, I think, still is struggling with 25 kmph only.
Okay.
No. Anything above 33 kmph is a very good schedule speed. 40 is excellent.
Okay. Thank you, sir. I think the Rakesh Pandey has raised a hand. I think Rakesh, can you put in your question? Rakesh Pandey.
Yeah. Just question to Navneet. So how many failures have been like, we have been talking about whether we should be considering uh, fallback or not. How many failures have been there? You have been in now metros for so many years, where we had to make use of fallback arrangement, especially the newer metros. I will say not. I will not say about, I don't know, maybe metros which were installed commissioned 20 years back, but metros like Kochi metro, of course, I know we had that flood and maybe that had caused some problems. But Kochi metro is now almost 4 years running. How many failures have been there of the system where uh, if it was like we had to make use of the fallback arrangement?
Yeah, that's a very pertinent question because the number of failures is important. But I can only share my experience that the a Kochi case itself, I can consider. Like, for example, we had a problem with the Wi-Fi backbone, in which one of the adjacent building had uh, 5.8 gigahertz transmission at very good power, which was causing a lot of problem in that particular area. So what you said is absolutely correct, that as the time is passing, the number of failures have reduced, because I know in 2005, 2006, when I had joined Delhi Metro, there used to be large number of onboard failures, but over a period of time, and also with the hot redundancy available on the onboard, these failures are far too low. There is no doubt about it.
Is there any
And
consideration then?
that is precisely why I said a time has come when we should decide that fallback is not needed. But then the confidence has to be there with the operator that once in a while, if there is a failure, they can handle the degraded operation.
Okay, thank you so much. I think now, is there any question for Mr. V.K. Agrawal?
Just I would like to make a comment here. What Navneet has said is very pertinent about the review of the requirement of the fallback system. In fact, with the additional ISM band of 5.4 gigahertz also being made available, like we are going for 5.4 gigahertz band for both for video transmission as well as for the CBTC. And basically in the underground sections, the interference problems are likely to be very low. So I feel that gradually going away with the standby systems.
I think I think said the right thing. I think the time has now come for all of us to think about how the spectrums have to be used, how the spectrum has to be shared, so that all the systems which are coming up now all over the country, all over the world, can make use of the spectrum optimally and in an effective manner. Thank you so much, all of you. I think now Mr. Somnath Banerjee would like to say a few words before we close down, because we have already exceeded the time. Mr. Somnath Banerjee, please. Thank you so much.
Somnath Banerjee, greetings from me. Somnath Banerjee, greetings from me.
You are muted. You are muted. Somnath, you are muted. Unmute yourself.
Thank you. Thank you. So I would like to thank all the participants and the excellent exchange of views that I was able to hear, and it's really a great experience today. We had seen very enlightening thoughts being exchanged, and it would be good if we do more of these and more often. And I would request that we get some suggestions from all the participants and those who may probably see this in future about the subjects they want to hear. Thank you so much. Thank you all.
Thank you. Before we call it a day, I would like
Thank
to
you,
make
Somnath. Thank you.
Thank you, Somnath. Nice to see you after a long time.
And thank you, Navneet.
Before we call it a day, I would like to make an announcement here that Institution of Railway Signal Engineers London is organizing an international conference in India in the month of February next year, that is February 2022, from 23rd to 25th. participation from all of us is required, and especially from technical papers. The focus will definitely be on the intelligent railway systems on the digital platform. I would request all of you to give it wide publicity and, if possible, make out papers of that standard so that we can discuss with the technical committee and with IRSC London. And on this particular conference, we have got the support of the Railway Board, a blessing from the Railway Board, and also the support from IRST India. Thank you so much, and thank you once again.
Thank you.
Thank you.
But again, for the IRC seminar, you must use the expertise of Kundan Chaudhary. He has been a star man. He normally used to be in this type of arrangement.
We will take care of all those aspects. Mr. Kundan Chaudhary is anyway on board.
Okay. Yes.
Okay, thank you so much. Thank you
Okay,
all.
thank you.
It was a wonderful session.
Yeah.
So I'm closing this meeting today. Thank you all again.
Thank you. Yeah.